This video covers Lesson 2-1 Warm-Up for Secondary 1 Math. Slope-intercept form. Number 1, we have the inequality -2 is less than w. And for this problem, we want to write the solutions in interval notation and graph on the number line. So we always start out with our variable, which in this case is w. We write as an element of. And now we're going to write our interval. So notice that w is greater than -2, so we're going to use a parenthesis at -2, and then positive infinity, and close with a parenthesis. Now to graph this, we mark -2 on our number line, go 1 above, 1 below, so -1 to the right, -3 to the left, and we'll have an open circle, since it's all parentheses in our interval notation, or it's just a less than sign, and then our arrow goes to the right on to positive infinity. Number 2, we have z is less than or equal to 6. So again, start with our variable as an element, so z is an element. Now here, it's less than, so we're going to do parenthesis, negative infinity, and then comma. Then we have, it has to be less than or equal to, so 6 and a bracket, because we're including the possibility of having 6 as a solution. To graph it, we mark 6 on our number line. 1 above is 7, 1 below is 5. We're going to actually have a closed circle here, since it's a bracket on the 6, or it's a less than or equal to, and our arrow goes left to negative infinity. Number 3, b is less than -9. So here we have b is an element from negative infinity, since our inequality sign here is pointing to b, or b is less than the number, to -9. Now we're going to use a parenthesis because it's just less than. There's no equal or equal to part. So then on our number line we have -9. To the right would be a -8. To the left is -10. We're going to have an open circle, arrow going left to negative infinity. Number 4, we have -1 is less than or equal to c. So c is an element from, and notice it's c is going to be greater than, it's pointing to the number, so -1 to positive infinity. Now I did error here. This is not a parenthesis. This should be a bracket on the -1 because it's a less than or equal to. So graphing it, we have -1. To the right would be 0. To the left is -2. We'll have a closed circle, arrow going right to positive infinity. Number 5, 4 is greater than or equal to 1. Well, 4 is not equal to 1, but 4 is greater than 1. So this statement is true. And since it's a true statement, we know that our solution is all real numbers. And so to write this in interval notation, we write that x, or a variable, it could be any variable here, is an element from negative infinity to positive infinity. And remember, we always put parentheses by our negative and positive infinities. To graph it, it's just a line going in both directions forever. I like to mark where 0 is, just to give us some bearing on our number line. Okay, so number 6, 4 is less than or equal to 1. Well, 4 is not less than 1, right? This is false. So 4 is equal to 1 is also false. So this is a false statement. So in interval notation, we're going to have a circle with a line through it. So there is no solution to this inequality. And to graph, well, we don't graph it because there's nothing to be graphed. Number 7, we have an equation we're going to solve, and we're going to write our answer in set notation. So let's go ahead and draw our line down from the equal sign. And notice on the left, the expression needs to be simplified. We can distribute -2 into the parentheses. So -2 times 3w's is -6w's. And -2 times -5 is 10, so plus 10. On the right, it is already simplified, so we're just going to bring it down, 6w's plus 10. Next, let's go ahead and get our variables to the same side, so I would add 6w's to both sides of our equation, which results in the equation 10 equals 12w's plus 10. Now we're going to go ahead and subtract 10, because now we want to undo or do the opposite of what's happening to the variable. So we're going to subtract 10 from both sides, because we were adding 10 to 12w's, which results in a 0 equals 12w's. And now we want to do the opposite of multiplying w by 12 and divide it by 12, which results in 0 equals w. Now to put this in set notation, we say the set w such that w equals 0. Number 8, we have a rational equation. So 6m divided by negative 3 equals m minus 26 over 6. So the first thing we want to do is find a common denominator, which notice our denominator on the left here is negative 3. The denominator on the right is 6. So a common denominator would be negative 6. That way we don't have negatives in our denominator. So we're going to multiply by negative 6 over 1, or negative 6. And on the left, though, I want to actually multiply by negative 3 times 2, which is negative 6. That allows us to simplify out the negative 3. So on the left side of our equation, we have negative 3 times 2 times 6m's, and we're going to be dividing that by 1 times negative 3, which is negative 3. So negative 3 divided by negative 3 results in 1. So we get 1 times 2, which is 2, times 6m's, so we get 12m's. 1 times 1 is 1 in the denominator, so we don't really need to write it, so we get 12m's. On the right, 6 divided by, or negative 6 divided by 6, we get negative 1 over 1, so negative 1. So this is negative 1 times m minus 26 all over 1, or just negative 1 times m minus 26. And now we distribute the negative 1, which is going to change the signs of what we have. So negative m, and then we have plus 26 equals 12m's. Let's get our m's to the same side, so we'll add 1m to both sides of our equation, which results in 13m's equals 26. Now that m is on one side of our equation only, we're going to do the opposite of what's happening to m. So right now we're multiplying it by 13, so we need to divide it by 13, which results in the equation m equals 2. So to put this into set notation, we have the set m such that m equals 2. Number 9, we have 3 times negative 4b plus 1 is greater than negative 14b minus 1. So let's go ahead and draw a line down from the inequality sign. And on the left, we're going to simplify by distributing the 3 through the parentheses. So we're going to get negative 12b's, 3 times 1 is 3, so plus 3, is greater than negative 14b's minus 1. Now we add 14b's to both sides of the inequality, and that will eliminate all of b's on the right side of our inequality and only leave b's on the left, and there will be 2b's plus 3 on the left is greater than negative 1. Now we're going to do the opposite of what's happening to our variable b. So we're going to subtract 3 from both sides of the inequality. We get negative 4 on the right and 2b's on the left. Then we're going to divide by 2, and we get b is greater than, and it stays greater than since we divided by a positive, negative 2. Now putting this into set notation, we have the set b such that b is greater than negative 2. Number 10, negative 7r's minus 3 is greater than or equal to negative 2 plus r. So again, we're going to draw a line down from the inequality sign, and here we're going to look at the left side. It's simplified. The right side is simplified. So now we're going to get the r's on the same side. So I'm going to add 7 r's to both sides of our inequality. So there will be 0 r's left on the left side. We'll have negative 3 is greater than or equal to negative 2 plus 8 r's. Now we want to do the opposite of what's happening to r. So we're subtracting 2, that's that negative 2 out to the left. So we're going to add 2 to both sides of our inequality. And we get negative 1 is greater than or equal to 8 r's. And then we have 8 r's, or 8 times r, so we're going to divide by 8. And that's a positive number again, so we're not switching our inequality signs, so we're going to have negative 1/8 is greater than or equal to r. Now set notation, the set r such that r is less than or equal to negative 1/8. This concludes the video for the Lesson 2-1 warm-up for Secondary 1 Math, Slope-Intercept form.